First and foremost, unfortunately, Martin isn't able to make tonight. So he kind of just asked me to do a session with you guys. And I thought maybe something worthwhile talking about is web components. And it's something that I'm kind of finding fascinating at the moment. I find regardless of whether you actually use it or not, it's a really great stepping stone to JavaScript libraries as well, because it essentially does a lot of the things that JavaScript libraries does, but it's just like a more straightforward basic approach, and then kind of JavaScript libraries are essentially the same thing, but just on steroids. And so I find regardless of whether you actually end up using it, I think conceptually there's a lot of value in terms of kind of covering it while you're learning like JavaScript libraries. I think that Martin is currently covering React with you guys. Cool, but so I'm happy to kick things off. As you can see, it's a bit empty here behind me. You might also notice that the audio is a bit hollow. So the wife and I just moved last week, so we're still in the process of packing out. So that's just an apology for kind of how the audio sounds and this beautiful scenery that you have behind you. Thanks, Matt. Cool. So let me share my screen and let's get this started. Cool. So I want to talk about a couple of things. So first and foremost, I want to talk about the problem. Like, why do we even need web components? And then I want to talk about web components as kind of an umbrella term for loads of different things. It's not a single thing. It's actually an umbrella that covers loads of little small things. And then I just want to kind of talk about the shadow DOM and like why the shadow DOM is so critical to web components. So is there anyone who knows who this guy is? Come on, guys. Huh?
No clue.
No. Guys, it's Tim BernersLee, the guy who essentially created the internet. Come on.
It looks like.
Oh,
look at that! Look at that high-tech look at that high-tech computer he's using, guys. Come on.
I just know the name, not the first thing.
Yeah, he doesn't look like this anymore. If you were interested, creating the internet does something to your aging process, and it's not good. It's very stressful. Yeah. So interestingly enough, the very first website that was ever created, which is what he created, is still around. You can follow this URL here at the top to actually go to it. Yeah, it's still there. You can visit it, and essentially, you see, this is actually a screenshot from like my actual browser itself. So you know, like this is the very first website that was created when you opened up the very first browser, which was actually called the World Wide Web. It was actually the browser that he created to kind of browse what was then the internet. This is what you would see, and you'll see here some amazing things like, you know, what is the internet? What is the World Wide Web? You know, like what are browsers? You know, like, so this is the first kind of page that we'd get. And, you know, and kind of like that kind of started kind of like this model that we still use today of, you know, essentially websites. And so the initial idea for websites was essentially an idea for the web as well. Interestingly enough, there were other kind of terms that were being thrown around. Sure, I can't remember now. I think there was something called like the deep mine, the information mine or something like that. There was something, information net or something. I can't even remember. There were two different names that were actually considered before the web. Or the World Wide Web. And, you know, and the idea is essentially, you know, it was intended to share documents, you know, so for academics, for whatever, like I think what today is kind of known as Wikipedia is essentially what the web was actually intended to become. Also, Sir Tim BernersLee very much thought about the web not only as a read-only medium, but like you would be able to make suggestions to websites and things. So very much like we think about like Word and Google Docs and those type of things. Like this is what the web was created for. You know, the web was never created for things like Figma, Trello, even, you know, Zoom or Google Meet or whatever. Even slides.com, which I'm using here, it was created for a place to a decentralized way to store and share documents and so forth. You know, and for a very long time, that kind of was the case. You know, there was peace in the world, and you know, people created websites about their dogs. They created like websites about Pokemon cards, whatever. You know, like if you were around back in the day of kind of like the GeoCity days, everyone had a website that said, "Welcome to my website," like, and then just some random stuff. So very much the web was kind of seen as a way to deliver documents, essentially digital brochures, you know, and you can see a lot of this still within the actual naming of things in the web. You know, even like the document API itself, which is the primary API, you know, the DOM, like the document object model, things like headers, you know, H1, H2, all of these things like are very reminiscent of this. And also for those of you who kind of have played around with floats or no floats, or had the very unfortunate reality of working with floats at some point in your life, this is actually where it comes from. You know, so the intent for floats was to kind of have images float to the side and have text wrap it. Like Flexbox is the first time that we've actually had a dedicated way to lay things out in 2 dimensions. Up until then, you know, like we used hacks, like the Flex, the float hack. So you need to do clear fixing and whatever. And that's crazy to think, is that, you know, like, I don't know when Flexbox became production ready, let's say about 5 years. Like, it's only 5 years ago that we, for the first time, got a dedicated technology to lay things out in 2 dimensions on the web, which is crazy. I know up until then, we've mostly been using hacks, using features of browsers, like for ways that they were never intended to be used. Like, because as you see, you know, with a document, like there's only one direction that content essentially flows, and that's downwards. You don't necessarily have a concept of sideways when you're thinking about like a Word document or something, or even a PDF. But, you know, like, that was only the case for a long time. That was only a case for a little while. And, you know, then we started getting a lot of problems, a lot of fights, endless Twitter wars about the web and whatever. So this is from pretty recently. You'll see May 25. Yeah, this is some heated arguments. And, you know, the source of this is essentially whether, so it was in response to what was it? I think TikTok API or whatever, and it used a button instead of a tag. And, you know, this is what this is all about. You know, like you have loads of people arguing that, no, you should use a button here. You have lots of people arguing, no, you should use an a tag here, and so forth. Yeah, some super heated arguments. And so for me, I always say that there is no right or wrong. You know, those are fighting words. Like a lot of people will get mad just from me saying that. But we're essentially using the web in a way that was never intended to be used. We're starting to use the web as a way to deliver software. I mentioned, you know, Trello, Netflix, so forth. So we're kind of using the web incorrectly. We're using it in a way that was never intended to be used. And so there's only degrees of incorrectness, you know, like is something more incorrect or less incorrect, not whether something is the right way to use the web or not, or the right or wrong way to write HTML. You know, we're kind of essentially building things that, you know, was never intended to be built on the web. And the reason for that is something that happened in my lifetime, which kind of changed everything. It was coined Web 2.0. So Web 2.0 was essentially seen as a massive change in kind of what the web is used for. I mentioned up until that point, you were essentially just using what would be called like digital brochures and whatever. And all of a sudden you started seeing like the web actually being used for things like Twitter, Facebook, YouTube, whatever, actual software. things that you would previously go to the store and buy and put on a CD and install in your computer were now being delivered through software, through the web. So you can imagine something like Trello, you know, like 20 years ago, you would have to buy that at Incredible Connection or whatever. Same with Figma, you know, you had Photoshop, Corel Draw, all of those things. And now we essentially have all of that in the browser. And not only do we have it in the browser, but weirdly enough, the browser implementation seems to actually be superior to all of them. I mean, the market share, Figma is just growing at an insane pace. I use Figma for almost everything. And even something like slides.com. In previous years, you would need PowerPoint or something that would be installed on your operating system. So all of a sudden, we started using the web as a software delivery platform. And actually, this kind of, like a lot of people predicted that this would happen. The actual term Web 2.0 was actually coined by this lady in Print Magazine, like even before the year 2000, so in the previous millennium already. You know, she essentially said, you know, what we know as the web at that point is a fleeting thing. And essentially the web will, you know, to quote her directly, become a transport mechanism through which interactivity happens. So this concept of the web becoming a software delivery platform, at some point people definitely realized, like, this is where things are heading. The problem being that that's never what the web was intended for. And we're not really there yet, you know, so we're kind of still on our way there. You know, there are some caveats to kind of building actual software in the web. There's some solutions to try and solve that, from WASM, which is kind of WebAssembly, but that's very high level and it only gets you there to a certain degree. You still have to do lots of things in JavaScript and so forth. So we're definitely not at the point where the web is like a fully fledged software delivery platform, but we're somewhere in between the world of static websites and, you know, digital brochures and actual software running in the browser. So we're kind of in this in-between phase. And, you know, in the world of academia, we tend to talk about this as kind of a liminal space. Which is kind of like a space between two things, which is always a bit weird and it's hard to pin down and so forth. But most of us have actual very relatable experience, and that is being a teenager. You know, teenagers are kind of like in this weird space where, you know, you're kind of a child, but you're somewhere in between a child and an adult, but you're not one of either, and you're kind of figuring out still who you are and whatever. Hint, like one of these is me. I'm not going to say who, not this one though. But yeah, like, so we're essentially at the teenager phase of whatever the web is becoming, which means things are a bit awkward. Like we're still figuring things out and so forth. You know, like kind of this is kind of what we're working with nowadays, you know. So if you look at something like Netflix, or you look at something like Figma, or even Google Docs or Trello, or even like the actual slides.com that I'm using now to present this, you know, this is a very far cry from what the web was initially created for. So let's go back to that, you know, like this. Or this. So the main problem there is we've never kind of had tools the tools that we've had to build these things were primarily for creating documents, even CSS itself, you know, like style sheets and so forth. We've never really had proper tooling to actually build software in the browser. And like the problem there is that, you know, like that's why we use things like React and JavaScript and so forth, is, you know, we use these abstractions because it's just so hard, like building software in the browser. So that's kind of what brings us to web components. And web components is kind of, I consider a first step to kind of addressing this problem, to start thinking about like, are there kind of more quote unquote software or computer sciencey ways of building things on the web, building actual software, you know, what you would consider like a web app. But nowadays with like PWAs and things, like the gap between web apps and native apps and things are also kind of getting fuzzy. It's also kind of like in that awkward phase. But yeah, so keep in mind, like web components isn't necessarily the ideal solution. I don't necessarily see it as kind of the final solution, but I think it's a really great step in the right direction. And I think like it's already pretty powerful. If you, for most basic things, for really advanced things, you're going to have to use something like React or so forth. Just because of the virtual DOM, there isn't currently some type of virtual DOMing or diffing functionality in the browser itself. And once your functionality gets pretty advanced, like it can really bog you down. So, you know, so then once again, just keep in mind web components, this is kind of where they're at the moment. All right, so let's get into that. So now that I gave a bit of an overview in terms of where web components are, like where they fit into the life cycle of like this thing that we call the web. So first and foremost, web components is an umbrella term. It's an umbrella term that covers loads of different APIs and things, but it's not like a technology in itself. There's no web component API. You can't go web component dot create or whatever. So the main canonical things that are kind of considered as part of web components, mostly by the people who actually maintain the web, like W3C, TC39, those people, is something called custom elements. I'll show you guys in a second what custom elements are. HTML templates. I'm not going to talk about HTML templates. I actually don't find them that useful. I've really been trying to figure out like some useful way to use them. I find like they just add more moving parts with very little benefit. So I'm not going to talk about HTML templates. Just keep in mind that is considered as part of kind of what we call web components. And then lastly, the shadow DOM. So I'm going to be talking about the shadow DOM, and I'm going to be talking about custom elements. So these things are generally considered like the three main things, the three pillars of what we consider web components. But then there's two other things that I kind of also consider as part of the discussion around web components and what makes kind of this concept of web components powerful. The first is ES modules, which you might know or not. I'm going to touch on that briefly. And the other one is something called constructible style sheets. So constructible style sheets is still very new. It's very much in flux. It kind of like they're kind of pinning down exactly how is it going to work and so forth. But I can just like I can see how it's going to really supercharge web components once it gets nailed down. It is something you can look into if you want, but because it's still so new, it's still very much just up in the air. I'm not going to be talking about that. So essentially, I'm going to be talking about custom elements, shadow DOM, and ES modules. All right, so let's start with custom elements. So essentially, you are probably already familiar with native elements. So these are things like divs, LIs, ULs, all of those things. So you have those elements, but then, you know, so if you were to imagine that these were the actual elements themselves, you have these classes that actually create them. And these classes create an object that actually puts that in the actual DOM. So the DOM is the document object model. So when you create a div in your document object module, it essentially creates an object for you. And that object, you can set the color, you can, you know, change the inner text and so forth and so forth and so forth. So it's important to distinguish between the actual element itself and the class that created it. So obviously you can use, like the browser uses the same class. So if you have 3 LIs or 7 divs, it uses the same class, you know, by means of constructor to build like all of them for you in the DOM. So yeah, so I quickly spoke about this concept of classes and DOM constructors. So, you know, in these essentially classes, you have these constructors that build a div for you or whatever, adds all the functionality that a div needs and so forth. So there's two ways to actually build it. First is just to pass HTML, which is essentially a string, and then the browser kind of reads through it and it builds that structure for you, or to just build that structure by hand. So to go document, create element. So here it actually does the construction, so it creates the element, and then you can do other things like put some text in it or whatever. Both of these two do the exact same thing. This is just by passing an HTML string, and this is by using the JavaScript API, so working directly on the DOM. This gets converted to a DOM. This gets converted to essentially a DOM, a document object model. Here you are directly manipulating and building the document object model by hand. This distinction is pretty important. I'm going to touch on it a bit later, just to understand there's two ways of creating things in the web, either by the JavaScript API or by passing HTML string by means of an index.html file or whatever. Okay, but so here is the important part. Now in 2021 and a couple of years before that, but it's really, I think, becoming production ready now. I think enough browsers have implemented it, is that you can create your own custom elements, and that is by means of window.customelement. So you have all these things like divs, LIs, ULs, spans, images, whatever, and you can now create your own one. I can create a sculpt-fenter component, or I can create a my awesome component, or whatever. I can essentially create my own HTML elements. So this is by means of the window.customelement, and I'm going to show you how to do that. So obviously, because it's on the window, you can just run it like this, same with document, whatever, because you are in the window scope by default in JavaScript. So you don't need to, you can either say window dot, or you can just write the thing itself. So essentially, this is by means of the custom elements object or class, and then you can just say custom elements dot define, and you say the name of the element that you want to define. So in other words, this would be what you use here in HTML. And then the class that's to be used as a constructor to create that in the DOM. And then you can use it like this. So essentially, if I run this code, custom element define, then it registers this for me in the browser, and I can do my element. I can use it in my HTML like as if it was built into the browser. So obviously, this isn't doing anything just yet. I haven't created the actual class to build this element for me, so I'm going to show you now quickly how to do that. And so let me zoom in a little bit. Okay, so let me just take this out of view. Okay, cool. So we have two things here. We have a div that just accepts hello world. Can everyone see my screen? Okay, cool.
Yes.
So okay. So this is just a plain HTML file. This is on CodePen. And then I have my element. So by default, if HTML doesn't recognize something, what it does is it just treats it as a div or a block element. So this is the fallback if we haven't created anything. So then going back to the previous example, so let's say custom elements. And let's say, oh, whoops, I'm typing this directly in HTML. So let's just do an inline script. You should try and avoid doing inline scripts, but it's just a lot easier to just demo all of this in one file. So let's do custom elements, and let's define. Okay, and let's say we want to create this now. So let's say my element. Okay, there we go. And then we need to pass it a class that gets used to create whatever gets added to the DOM. And let's just for now call it my element. All right. So there we go. And let's just close that. All right. So we are defining it, but it's not doing anything. So let's create that class. So you guys should be familiar with classes at the moment. So let's do class, and let's just call it my element, because that is essentially what we then, so this is what we're going to use to create this for us in the DOM. All right, so we need a constructor. Every class needs a constructor. That's just the way it is. You can't have a class without a constructor. And then we call super. Okay. So, well, before I get into that, let's say, obviously, we don't want to just have a base class. We want to actually extend HTML element. Okay, so we just take a base HTML element with no behavior and we extend it. So this is the base level thing that's used to create objects for us in the DOM, create elements for us in the DOM. And then in our constructor, we just want to run super. Okay, so what super essentially does, all that super does is it says that just run the constructor on this as well. So for example, if I say class and I say 1, okay? And class 1 is a constructor and that's just console log 1. So now if I do class 2 and that extends 1, by default, let's have this one console log 2. All right. So if I were to do new 2, it would actually, can I see the console in here? No. It would actually just do 2. So in order to run the constructor on the actual thing that it extends, I need to do super. So super just runs whatever it extends, it runs that constructor as well. Okay, cool. So in the same way that if this was just HTML element without any custom behavior, the constructor would run automatically here. But just because we extend it, we need to run super as well. If you still don't understand what this exactly does, don't worry. Just remember you should always run super. That's all. If that's all you take away from this, that is 100% fine. You don't need to understand what it does. You just need to understand you need to do it. All right. So then we want to add a method. Connected callback. So this is part of web components. And connected callback, what we want to do is we want to, this is going to fire whenever this thing mounts. So, you know, if we get rid of this, connected callback is never going to fire. But if we run it, that's going to happen. If we run it, connected callback is going to fire 3 times. Okay, so that just fires when it actually mounts in our DOM. So in other words, this fires once it's created, and then we can do whatever we want. So up until this fires, we don't have access to the object in the DOM because it hasn't been created yet. So you shouldn't put your logic, well, most of the logic we're going to be covering in this exercise is not going to go in the constructor. If you're unsure, just put your logic in the connected callback. So what we want to do here is we want to say this. Well, let's first create our div. Okay, cool. So we want to replicate this hello world. We want to create a, let's also change custom element. Let's just call it red div. Okay. So let's say we want to register red div, and this is like a usual div. The only exception is that it has a red background by default. Okay, so it's kind of extending the regular div. Let me just see. So this should be a red div. All right. So by using the JavaScript API, we can do the following. So let's create our element. So let's say document create element div. And let's also create the text that's going to go inside it, const so text. And here we can actually grab what gets passed here to red div. So we can just get the inner text. So we can say, let's say create text node, and what we want to put in the text node. Let me just zoom out a little bit so my styling doesn't get all messed up. We just want to get this. So in other words, the object, the DOM object associated with this, and we just want to get the inner text. All right, so now we have our element. So now what we need to do is let's add the text. So we say append child text to our element. We also want to say element style. Well, before we do that, let's just say then this. So in other words, the object associated with this. Remove child. So we want to remove what's currently in there. Okay, so we're going to say remove child, and we can just say this first child. There's only one thing in there. Okay, cool. So for now, it should just wipe it completely. Whoops. Pressing Control S. I'm so used to VS Code. Okay, let's go ahead with this. So let's just go this. Oh, no. So the new element. So element style dot background, and let's just set that red. And so let's remove the current thing, and let's this append child element. So we remove what's currently there, and then we just, that's not working. So this is actually good that it's not working. I probably made a typo somewhere or something. Element append child, create element, this first child. I can't remember now. Okay, but so here, this is actually a really good example because it just shows like how unwieldy the JavaScript API can get. Like HTML exists for a reason, and that is because HTML is a lot more expressive. So for example, we can actually just go this inner HTML, and let us just do, so let's do this dot inner HTML, and let's just do a backtext, and let's do a div, and close that div, and we can just do interpolation here to have a dynamic value, and we can just make this inner HTML, so it just gets the inner HTML here, and let me just see if this actually works. Okay, cool. So it does work. So now I actually just, so what we can do is just, let's just do style background. All right. And there we have our red div. So first and foremost, like this, I'm actually glad that it didn't work when I did the JavaScript API, because, you know, to illustrate the point, it's a lot harder working with the JavaScript API. I probably made a typo somewhere or something. But, you know, so now we can use our red div. We can have 3 of them, and we can say 1, you know, 2. We can put a red div inside this div. You know, we can use it like any regular HTML. Like we've essentially just created our first web component. And, you know, but it's very simple. It's just a regular div, and it just makes everything red. So like this feels like a superpower. You know, we've essentially created our own HTML here. And, you know, this is one HTML file. There's no Babel, there's no Webpack, there's no like anything special. You know, given that I just kind of showed like how cumbersome it is to use the JavaScript API, why would you actually use the JavaScript API when you can just go inner HTML and write out like just HTML as a string? So the reason for that is because it's a lot more performant. So when you do the inner HTML, every single time that the component re-renders, you are effectively creating new HTML each time. When you use the JavaScript API, you have a lot more fine granular control. So you can just say, so let's say, you know, when you change the color of something, if you use inner HTML, every time it needs to rebuild the entire thing with the new color and replace it. When you use the API, you have a lot more control. So you can just do the little changes that you need and so forth. Generally, this isn't a problem. Generally, I go with inner HTML as kind of illustrated now. I find it a lot more readable. I find it a lot more declarative. It's just a lot easier to understand what your code is doing and actually to write the code. But beware that, like, sometimes, especially if you're doing like rendering a lot of things, performance can become a problem, and then you might need to jump into kind of the JavaScript. Might need to jump into kind of the actual JavaScript API. And I tend to follow the words of a well-known software developer called Kent Beck. And he essentially said, make it work, make it right, make it fast. in that specific priority. So first priority, just make it work. Second priority is make it right. In other words, by making it right, or some people say make it pretty. Some people say make it work, make it pretty, make it fast. So once you get it working, then make sure that it's readable. Make sure that it's, people can understand it, other people can work on it. If you come back to it, you understand what's going on there. And only then, third priority is making it fast. So in my world, following that advice, making something pretty, making something readable trumps making it fast, unless like this performance of it becomes a real problem. Then I would go and I would look. And then another thing you might have noticed that I use dash. And this is essentially what separates custom elements from native elements. So, UL, we have LIs, we have image. What else do we have? We have H1. Currently, no native HTML element is separated by a dash, or a hyphen is the actual correct thing. I always keep on calling it a dash, but it's actually a hyphen. So that is just a way to ensure like it being future friendly. So for example, if I create my red div and it was named like that, maybe in 10 years, browsers add something called red div to the browser. Now what's going to happen? All my code is suddenly going to break. So by including dashes in the names, we ensure that it's never going to conflict with anything natively getting added to the browser. So that's just one thing to keep in mind. Like you should always, your custom element should always have a hyphen somewhere in the name. It's weird that that's the way they decided to do it, but it's also ingenious, in a certain way. But that's just how you distinguish custom elements from native browser elements. Then, this is probably going to show my age a bit. Back when I was in university, this used to be the hottest meme that you could drop. And that was kind of like the exhibit meme about, yo dog, I heard you like. So we put the in the whatever. Essentially, it just comes down to, I don't know, how do you even explain a meme? But essentially, like, this is just a joke. So the shadow DOM is essentially just a DOM inside the DOM. So you create your own DOMs inside the DOM. So I just made a boomer joke. I'm not a boomer yet, I guess. But I'm once again, if you want to talk about awkward, I'm kind of weird, in a weird place between like kind of Generation Z and boomers. So I'm kind of like also in a liminal space where I'm like half boomer, half like hip. So I just said, yo dog, I heard you like DOMs. So we put a DOM in your DOM so you can DOM while you DOM. So let's talk about the shadow DOM. So essentially the shadow DOM is just DOMs inside your DOM. The DOM is essentially the document object model. So for example, if I were to have, let's just get rid of all of this. If I were to have a UL and LI, this is my DOM. If I were to open this in Chrome, there's a lot of stuff going on here because there's slides inside Chrome, inside CodePen and so forth. But, essentially, like this would be my DOM. But the thing is, we've had shadow DOMs for a very long time. And you can think of shadow DOMs almost like iframe. So if you've ever worked with the iframe, you can't access anything in the iframe from your actual code. And the same here, these are just native shadow DOMs. So, we can see there's a lot of things going on here. There's like buttons, icons, there's actual text in there, and this, but it's just a single HTML element. And this is a pain, like for those of you who've ever tried to style like file uploaders, I clicked it and I tried to upload a file. No! Like this is a pain because you don't have access to these things. If you say background red, it's just going to make red behind it. You can't change this text. You can't, and that's because it's in a shadow DOM. So it's completely hidden away from the actual main DOM that you're using over here. And because it's native to the browser, they obviously don't give you any access to it ever, no matter what you do. But, shadow DOMs work on the same principle. But these are native shadow DOMs. With the shadow DOM API, we are able to create our own shadow DOM. So once again, like if we have a red div, this is obviously not going to work because this is a new file now, and we say hello. Whatever red div does here, theoretically, we shouldn't be able to access from outside. So we shouldn't be able to go in and change the color of a red div directly from here. So this is something called encapsulation. And I'm going to quickly talk about that. So yeah, so if we just have a look, this is the original, just the actual DOM as we know it. And then with kind of shadow DOMs, we kind of have these little nested DOMs inside our big DOM. So why do we want this? This seems like a lot of complexity. And so there's also quite a well-known quote that I kind of try and live by, and that is essentially the trick to building large software is to never build large software. And that sounds paradoxical, and intentionally so. But the point being that building large software is like a fool's errand. You're going to burn yourself if you try and manage software at a large scale. What you should instead do is build small little pieces of software and compose all of them into something bigger. But they should be independent on their own, and they should just talk to the bigger thing. They shouldn't talk to one another. And this is the principle of encapsulation. But essentially, like it's just like the fact that we have these things that are abstracted away, like it actually makes it easier to maintain, because we know if this thing breaks, then something's happening in here. If this thing breaks, something's happening here, and it shouldn't ever influence the things around it. If you have thousands and thousands of lines of code and you don't have this, if something breaks, it can be anywhere in that thousands and thousands of lines of code, which is a nightmare. And the reason for that is because we want to avoid like dealing with low-level complexity all the time. So, you can imagine if you, like, this is pretty topical for me because I just moved into a new place. If I want to take a shower, I don't need to understand how all the piping is connected, where the geyser is, how the geyser actually works, what happens when I turn the tap, like, where does the water even come from? Like, to what municipal pipe is it connected? I just work with like an abstracted interface, and that is the tap in the shower. And I just turn it one direction or another direction. And that's all I need to understand to be able to use the thing. It's the same with computers. Computers is also kind of like computers also abstract away a lot of low-level complexity. So for example, this thing that we're using here is like built through like logic gates, circuits going left and right, and motherboards. But in order to use it, we don't need to understand how all of that works. We use it through an abstracted interface, and that's generally an operating system. So we click buttons, we enter things on the keyboard and so forth, and all of that happens in the background. But we're not actually being cognizant. We don't need to, keep in our mind all the time, like what is actually happening when we're doing that, because we can only keep so many things in our mind at a certain time and be cognizant and mindful of so many things at once. And your software can grow to a point where you can't think of all the moving parts at once. It's just too big. For anyone who's ever written a book or a thesis or something like that, you'll know what I'm talking about. Like, it's almost like you can't think of all the things you're discussing at once. You need to you can only focus on one chapter at a time, and then you need to almost forget about everything else. And once again, so we want to abstract all of this away. So we want to build this, but we want to build it in a way that it's abstracted away, that we kind of only interface with it through a simple interface. Maybe we say, do this, do that. Maybe we pass this value, and so forth and so forth. And actually, the web components allow us to do that. This is a good example. It's a very rudimentary example, but it's a good example because, I think I have one that's working with the JavaScript API, which is why I kept this code. there we go. Cool. So we don't need to understand what happens here. If someone else wrote this web component for us, they can just say, hey, use the my element, and it's going to do this thing. We don't need to understand how it actually does that. And so we want to kind of, as we build our things, we want to start actually like creating abstractions as we go. So we can just interface with these, like, for example, we can have my element and we can just pass like color, we can say it needs to be red, or it needs to be blue, or it needs to be rainbow, or whatever. So now we're abstracting away all of this complexity and we're just dealing with a simple abstraction. So as you go, you want to build these levels of abstraction. And web components provide us with that. Up until this point, before web components, we had to build all of that by hand as we go. We needed to be aware of every single low-level thing. It's almost like, once again, if I want to take a shower, I need to now actually, for whatever reason, know exactly how all the parts are connected, where to put every single thing, where the water needs to flow, and so forth. So essentially, in here, I needed to understand, well, I have no idea what's going on here. Well, my point exactly. I needed to understand all of this, because if I want to make a button that does something, I need to understand how it interacts with the entire system. Like, what are conflicts that can happen? Where can weird things happen? What are weird side effects and so forth? Because it's not abstracted away, it's not encapsulated. So it interfaces with everything at once. So web components allow us to avoid that. So, that's essentially the Shadow DOM. Unfortunately, I don't think I'm going to have time to actually document how to use the Shadow DOM. Let me just quickly see if there's maybe just a link I can share with you guys. Let's just see Shadow DOM tutorial, Google Shadow DOM tutorial. There's not a specific one that I had in mind. I literally just Googled and clicked on some of them. So there's no point in me actually sharing a link because I don't know which of these are better. But all I wanted to indicate is that there are loads of material on this. So then lastly, I spoke about the Shadow DOM, I spoke about custom elements and how these two things allow us really powerful functionality when it comes to web components. Then in closing, I just want to speak about two other things that I personally feel actually make web components really super powerful. The one is ES modules. So for those of you that don't know, ES modules is so modules is essentially a way for us to have our code be in separate files. So, in the early days of JavaScript, all your JavaScript needed to be in one big file. Obviously so we had the script tag. The script tag had lots of problems. It didn't necessarily do what's called dependency management for us. So we needed to include things in the correct order. We also couldn't import scripts from within scripts and so forth. It's, if you want to have a dependency chart of all the different files that you're using, you needed to really it's very easy to accidentally import one script in a place where it shouldn't be and so forth. So ideally, in a quote unquote real programming language, you want to have something that kind of manages that dependency for you, figures out what needs what and so forth, and then loads things in that order without you having to manually tell it when to load things. So we kind of looked at augmenting it by means of technology. So kind of libraries, frameworks, things, so one of them was one called AMD, which was asynchronous module definitions. It's the most well-known library that used that was one called Require.js. I think it's still around. I don't think anyone uses it. You'll see it's still compatible with IE6. But so that's one of the early ones that they kind of looked at using a library to do this type of thing. Then we also got something called CommonJS, and this is what Node uses. You might be familiar with it if you've ever written some Node code. So, you know, it's where you do like const and like equals, and you say require and the name of the file. So this was worked out really well in Node, and you know, it kind of seemed like it was a really good solution. AMD like kind of failed a bit for various technical reasons. It just didn't pan out. Performance was absolutely horrible and so forth. So CommonJS seemed like a really good solution. Problem is it was only used with Node. You couldn't use it in the browser. And then we got something called Browserify, which essentially just took CommonJS and made it work in the browser. But up until this point, we needed libraries, we needed build tools. The browser itself couldn't do this manually. So what a lot of these just did is they just handled this dependency tree for you beforehand, and it plonked it together in one big file, and that file was given to the browser. The browser didn't do that. All of this was done beforehand and so forth. So this is where ES modules comes in. It is a native solution. It isn't, we're not using libraries or whatever. It's built into the browser, but it's a lot beefier than like what we initially had with scripts. Module resolution is the actual word. Module resolution for us, figuring out, okay, in what order should things be loaded. You might have encountered it. It looks like this. You might, if you've used React or whatever, you might think it's something specific to React. There's only one slide left. Don't worry, guys. You might think it's something specific to React. You might think it's something specific to Webpack. It's actually native to the browser. You can use this in a JavaScript file today without any build process, without any like Babel, post-processing, whatever, and it's going to work 100%. Cool. So let me just finish the last slide, and then I can maybe take some questions if anyone wants to still hang around. So why is this useful? This is useful because now we have that encapsulation, we have those custom elements, we have all of those things, and but now we can actually have them be in separate files. So I can, you know, like nest my things, you know. So for example, what I usually have in a project is I have kind of like a base component that I extend, that I use like for all my components. Then I have a specific component that I use for views. And then, you know, like I have my reusable components, a custom button, custom icon, mobile menu, user card, all of that, and I have my specific views and so forth. So now, not only do we have encapsulation, but we can have that encapsulation by means of files. We don't need to put all of JavaScript in one file. And furthermore, because this is native to the browser, we don't need to have an npm run or an npm start. We can literally have an index.html file, and we can have a scripts.js file. And, you know, and we can get all of this. I was hoping I could do a demo here at the end, but yeah, it was quite a lot to cover. I tried to go really fast, but I think we are out of time. I can maybe, like, we can maybe have a bit of a discussion now. But yeah, like there's still so many things that I wish I could have mentioned. So yeah, I'm curious whether anyone has any questions. So someone asks for a demo. Unfortunately, we are out of time, and my wife is going to get very angry if I'm still here at 7 o'clock. So maybe I can do a demo in the next session. I'll maybe chat to Martin. Maybe we can do a part 2 where I just do an actual demo of all of this. But it's quite a big topic, and you kind of want to understand how the pieces fit together before I do a demo. Otherwise, it's just going to be lost on all of you guys. But like in the meantime, I would highly encourage you guys to watch a couple of YouTube videos on web components. Maybe like just Google web components tutorial. There is like this link I'll share. There's a really good one on CSS tricks. And I think it's something like web components are not as hard as you think they are. Oh, web components are easier than you think. Let me share that in the text chat over here. Let me also share it in Slack. I would definitely check this out. This was kind of my entry point to web components. It really explains it like very well. It really breaks it down very like, well, there's another one as well, and I think it's this, an introduction to web components. Yeah, so here, you know, so it starts with like, what is web components? And it talks about templates. Once again, like I would just skip templates. I don't find them that useful. Part 3 is about custom elements. And then part 4 is the shadow DOM. And then there's just some other tooling and so forth. I would definitely check this out as well. This is a really great read. Yeah, but that's about it. I can maybe do 5 minutes, 10 minutes, quick questions if anyone has any. Yeah. Oh, hi, Xander. I don't know how long you've been lurking there.
I just showed up. I had a minute and I thought, let me see what's happening.
Okay, so yeah. Like maybe you can do the demo for us.
Afraid not.
Yeah. Yeah, I'm curious. Is there anyone who has any questions?
When you're talking about the ES
Yes.
module, is that basically where ES6, ES7 and all that sort of comes from? So every time they just take whatever they wrote before and then just manipulate it to get you different ES6 and whatever else module?
Yes. So the ES part, so that's actually it's such a tricky thing to unpack. So ES is actually the real name of JavaScript is actually ECMAScript. JavaScript was actually Netscape's specific implementation of, like, it was a Netscape specific thing. And then Internet Explorer created their own thing called JScript and so forth and so forth. And then it was all unified into a single language called ECMAScript. But like, it's just, the name never really caught on. People still call it JavaScript to this day. So that's where the ES part comes in. ES just essentially stands for ECMAScript. Because technically, if you want to be technically correct, JavaScript refers to the Netscape implementation of this, Netscape not even being around anymore. So essentially ES6, ES7, those are all quote unquote versions of JavaScript. I say that with a lot of quotes, but yeah, like it's not that simple. But so ES essentially just refers to JavaScript. It's ES modules, essentially ECMAScript modules. So it's essentially just JavaScript modules. So yeah, it's kind of loosely related to what you mentioned, but that is something different. Yeah. You can, for all intents and purposes, you can imagine the name is also just JS modules.
Yeah.
Okay.
And the other thing is, when is the best time to use web workers? If you can do the same thing with React or one of those frameworks, isn't it easier doing it in React than it is with the web worker?
So you're talking about the web components.
Yeah, the web components.
Yeah, web workers is something else. So when's the best time? When you're just learning. So okay, let me backtrack a bit here. So it's a hard question to answer at this moment because, you know, sure, it's such a hard question to answer. Okay, when is the best time? So I can personally speak for myself. If I'm doing something really complex and I know performance might become an issue, I am going to be using React. React just is essentially like web components, but just with superpowers. So it's, you know, augmented. It's almost like it has an exoskeleton almost. That's, you know, extra on top of it. So then I would use something like that. If I don't want to worry about build tools, I don't want to worry about Webpack. and so forth. I just want to write regular JavaScript. I would use web components. And if it's a very basic app, so a to-do list or whatever, I would use web components. And I think where web components work really well is when you already have some type of server-side language and you just want to like put some widgets in there. So let's say you have a WordPress site or whatever, and you maybe have like some type of widget, like a calendar selector or whatever. And, you just want to pop that in there. You don't want to have like a full on templating language and all of that. In that case, React is going to be pretty big. It's going to be a bit overkill in terms of size and all of that. So you might just want to write like some regular JavaScript web component code and pop it in there. It's a hard question to answer because first and foremost, it is quite new, so it doesn't necessarily have the market share that something like React has. And the other thing as well is why it's a tricky question to answer is it's not apples and oranges, like things like React and so forth. Most of us know all of them pretty well already. So we're not starting with the option of web components or React as kind of like two mutually exclusive options. I found it's the same with jQuery for a very long time. A lot of people who used jQuery thought that it was easier to use than the actual native JavaScript API. And that's just because we were so used to it. It was almost second nature. For people that actually haven't experienced jQuery, they actually found that jQuery is a lot harder to understand than the native JavaScript API. So my answer to that would be, I think the two times where it's maybe of most value to look into web components or learn web components is firstly, if you don't know any JavaScript library at all. I think web components is a really great stepping stone to that. It's a much more gentler introduction to components and things like re-renders and those type of things than just jumping straight into something like React. So I would maybe start out with web components as a stepping stone. And then also another time where it might be really worthwhile looking at web components is if you have a server-side thing or you have a monolithic framework or something, and you just want to add a bit of JavaScript code. You don't want to go full on routing and all of that. Web components is a kind of very lightweight and easy way to do that. Yeah, you've probably noticed it's a pretty hard question to answer. Yeah. Cool. If there is any other questions, I can maybe just do one quick one before I need to go grab dinner. All right. Okay. Seems like it's dinner. All right. Thanks, guys. Yeah, I'm probably going to join you guys next week again. And then maybe I'll also chat to Martin about maybe having a part 2 where I actually demo how I build something with web components. But yeah, otherwise I'll chat to you guys on the Slack channel. Okay, awesome.
Thanks a lot.
Cool. No worries. Thanks, Patrick. All right, guys. And yeah, I'm on, if you guys are on ZATech, I'm just Skulk Venter. You can just send me a DM, any questions, just reach out directly to me. I love chatting about these things. So don't feel like you're kind of intruding or anything. Just send me a question. Okay, guys, have a great, what's today? Thursday. Have a great, yeah. I know I was confused because these usually happen on a Monday, and then I was like, wait, yesterday wasn't Sunday. What's going on here? Cool. Cool, guys. Have a great Thursday, and then have a great weekend, and I'll see you guys then on Monday again.
Okay, cool. Thank you, man.
Cool.
Goodbye.
Cheers, guys.